Today's notes are on multi-step equations. Equations are two expressions that are equal to each other, like x is equal to 4, or that means 3x is equal to 12, and 3x plus 4 is 16. Multi-step is when it takes multiple steps in order to solve those equations and get the variable isolated by itself. Here's a part A and part B of our first example. Now for these problems, we're going to combine our like terms and then isolate our variable. Let's look at problem A. My like terms are 4x and minus 6x, giving me negative 2x. I bring down the minus 8 and the negative 10. Now that I've combined like terms, I have a two-step equation to solve. I start by adding 8 to the negative 8. That cancels to make 0. And then I add 8 to the other side of my equal sign, leaving me with 2x on the left side of my equal sign and negative 2 on the right side. Now, if I have 2x, that means there's 2 of them. I isolate the variable by dividing, giving me a final answer of x equaling negative 1. So I combined my like terms first, and then I solved the two-step equation, isolating the variable. Let's look at part B. Negative 9 plus 3y plus 4 equals 16. I look at the left side of that equal sign and I can combine my like terms. Now the y's don't have anything to combine with, so I just bring down the 3y. But I have a negative 9 and a positive 4. They combine to give me negative 5. The 16 doesn't get combined with anything because it's all alone on the right side of the equation. My next step is to add 5 to both sides to leave me with the 3y by itself and get rid of that negative 5. And that gives me 21. When I divide to isolate my variable, I get y to equal 7. For my problems in example 1, I combined my like terms and then isolated my variable per usual. There's now this additional step that we kind of saw when we talked about simplifying expressions. We're going to distribute first. Let's look at example A. I distribute the 5 to the x and then a minus 3, giving me 5x minus 15. I bring down what I haven't used yet, plus 15 equals negative 10. Now when I go to combine my like terms, you'll notice that negative 15 and positive 15 already make 0. I don't have to add 15 to both sides because it was already present on the left side. When I bring down the 5x I haven't used, it equals negative 10. When I isolate my variable by dividing, I get x to equal a negative 2. Let's check example B. Again, my first step is going to be to distribute. The negative 2 multiplies by the x to give me negative 2x, and the negative 2 multiplies by the negative 4, giving me a positive 8. I bring down what hasn't been used, the plus 6x and the 16, and keeping the equal sign where it was. Now I can combine my like terms. I have a minus 2x and a plus 6x. That gives me 4x, and I bring down the plus 8, equaling 16. I continue isolating my variable by subtracting 8 on both sides, leaving me with just 4x and 8. I divide by 4, and x is equal to a positive 2. You'll notice that after you do the distributing and combining like terms, you're ending up with those two-step equations that you've already mastered and been practicing. Here's a problem for you to try. Pause the video, try it on your own, and play to check your answer. Let's go over it. My first step is going to be to distribute. I'm not going to combine like terms yet because there's distribution that has to happen. The plus 2 gets multiplied by everything in the parentheses. The negative 6 wasn't used, so I bring it down. That 2 times 2x is 4x, and the 2 times 1 is 2. Then I also haven't distributed anything to that minus 3x, so it comes down as well, along with the equals 9. This time, when I go to combine my like terms, I have multiple sets of them. I have a negative 6 and a positive 2 that combine to give me negative 4, but I also have a positive 4x and a minus 3x, leaving me with a positive 1x, or you might just see written as x, equaling 9. In fact, most times when you see this equation, it's going to simplify to 1x minus 4, because mathematicians normally like to put the variable at the front. Either way you have it written, like it is in the yellow and green or as it is in the black, my next step is the same, to add 4 to both sides, leaving me with 1x equaling 13. And since 1 times x is just x, I don't even have to worry about division. X is just equal to 13.